If the coefficient of static friction between a 50-pound crate and the floor is mu sub s is 0.40 and the coefficient of kinetic friction is mu sub k is 0.30, part B, if Cuthbert pushes horizontally with a force of 25 pounds, what will be the acceleration of the crate? The givens. The weight force F sub W is 50 pounds. The coefficient of static friction mu sub s is 0.4, no units. The coefficient of kinetic friction mu sub k is 0.3, no units. And the pushing force by Cuthbert is 25 pounds. We do not know that the velocity along the x-axis is constant. We need to look at this more closely. We have not established that the frictional force is a kinetic friction force or a sliding friction. We need to look at that more closely as well. We also know that the velocity along the y-axis is 0, regardless of whether or not the crate is at rest or is moving along the horizontal surface. Crate is not moving upwards or downwards, so it is at rest in the y direction. Therefore, the acceleration is 0 because the final velocity along the y-axis is 0, as is the initial velocity. The unknown, what will be the acceleration of the crate? That is talking about the acceleration along the x-axis. It cannot accelerate along the y-axis because it's moving or sitting on a horizontal surface. A sub x is what, is the question. Before we look at what equations we need, we also need to know, is the crate at rest or is it in motion? If the crate is still at rest, then a sub x along the x-axis is 0. If it's in motion, we need to determine whether or not it's moving with a constant x velocity or whether or not the forces along the x-axis are unbalanced and therefore it is accelerating. Let's first address the question, is the crate at rest or is it in motion? The equation to find that out is that maximum static friction. Symbolically, that's F sub F. That is mu sub s, the coefficient of static friction, times the normal force. The normal force is a vertical force. We look at the y-axis and we notice that the velocity along the y-axis is 0. The crate is at rest along the y-axis. The first law says if the velocity is constant, then the total force is 0. Therefore, the net force along the y-axis is the normal force upwards minus the weight downwards is 0. Therefore, the normal force is the weight in magnitude, or 50 pounds. We substitute the 50 pounds for the normal force, and we get that maximum static friction, F sub F, is 0.4 times 50 pounds, or 20 pounds. Since Cuthbert's push is 25 pounds, which is greater than 20 pounds, we conclude that the block is in motion. Now we know the next question is, does it move with a constant velocity? If so, that would mean that the forces are balanced along the x-axis. Or are the forces unbalanced and therefore the crate would move with an acceleration? We know the pushing force is 25 pounds. We know that we have a sliding friction since the crate is in motion. Therefore, we need to find out what is the frictional force. We write down the formula for the frictional force for kinetic friction. F sub F is mu sub k, the coefficient of kinetic friction, times the normal force. We substitute mu sub k from the givens is 0.3, no units, times the normal force. We know that that is 50 pounds, or the weight. We get that the frictional force is 15 pounds. Remember that so long as the coefficient of static friction does not change, frictional force is constant regardless of the velocity. So we've established that the pushing force is 25 pounds positive, the frictional force in magnitude is 15 pounds, but that is negative in direction. Therefore, the force is unbalanced. Therefore, the equation that we need to find the acceleration along the x-axis is Newton's second law. We now substitute into the second law along the x-axis, or F net of x is, we go to the free body diagram to see what the net force along the x-axis is. That's the pushing force, positive, minus the frictional force, negative. So we write F sub P minus F sub F is mass times A sub x. We substitute in. Pushing force is 25 pounds. We have established is 15 pounds. That's the mass times the acceleration along the x-axis. So what is the mass? We need to establish that. We look up here, we don't have that. To find the mass, we recall that the weight force is mass times the acceleration of gravity. We solve that for the mass. Mass is the weight force divided by the acceleration of gravity. We substitute in, the weight force is 50 pounds. The acceleration of gravity in the British system is 32.2 feet per second per second. And we get that the mass is 1.55 and the unit is slugs. Solving for A sub x, we get that It is 10 pounds divided by 1.55 slugs. That gives us a magnitude of 6.45. But what are the units? Remember, F as MA says that a pound of force is a slug times a foot per second per second. Substituting that in for the pound, divide that by the slug, we get a unit of feet per second per second. What we get is that the acceleration along the x-axis of the crate is 6.5. That's two significant figures. Since the problem is a two significant figure problem, feet per second per second.